Alright, hey guys, my name is Ronald McHaskett, and I will now be doing a blueprint showcase for the jetpack level you just saw. I'll try to get through this as clear, quick, and precise as possible because we have a lot to go through, so anyway, I guess we'll get started. Starting out here in the third person character blueprint, it is the biggest blueprint I have, but it is also the most important because it has the key game mechanic, the jetpack. So with that, I guess we will start with the jetpack itself. So starting out here, the jetpack works on a toggle with the E key. So when the E key is held, it runs this line of code right here that sets the player movement to flying, and when it's released, it sets the movement mode back to walking. So that's fairly simple. Next up is the thruster particles. So this is where the sparks come from the back of the jetpack come from. So same principle as before. As the E key is held, it activates the particle effects on the back of the jetpack, and when it's released, it turns them off. So yeah, up next we got the timer for my E key held event. So what this timer does is it runs a code for an event that iterates through the code for the amount of time that the timer is being run. So here I have it going to my overheat event, which iterates this line of code down here every 0.5 seconds. And then this clear and invalidate timer is here for clearing the timer for my E key release event. So they both do very similar things, but this clears and invalidate the timer. But this clear and invalidate timer is here to turn off the timer for the E key release branch down here, so that we don't have conflicting timers going at the same time and breaking the mechanic and the game. So yeah, next up is this code that is being iterated through each time. So I have a function here that raises the current fuel value by the depletion rate and sets the new value. So as the button is being held, it raises the heat gauge through the timer, iterating the code every 0.5 seconds. Let's get back to the event graph here. So then we have a branch statement that follows another line of code if the current fuel gauge reaches 100. So this initiates an overheat death sequence for the player. So in this instance, it sets the movement mode back to walking so the player cannot fly anymore after overheating. It deactivates the thruster particle effects, clears the E key pressed event timer, and initiates the player death function. So this function has a further chain of events for the player death, but breaking it down to a function helps clean up the code and make it look a bit more manageable. So here it plays an explosion effect attached to the character to show that the jetpack exploded. It then sets the collision mode of the mesh, so there isn't any graphical weirdness with the ragdoll. Then we have the actual ragdoll itself. Then it adds the specific game over screen for when the player overheats, and then sets the game mode back to UI and game only. So yeah, that's that. And back over to the event graph. I have an event for clearing and invalidating the timer for both instances of the E key being held and E key being released. So I have these here more or less as a check to make sure the timer does clear because, like I said earlier, if there's a weird instance where it doesn't clear and another timer tries to spawn, it can really break the game, especially when the player is initiating a big line of code for when they die. So yeah, that's why those are there. So anyway, moving on. Let's go over to this branch for when the E key is released. So here we have another timer that initiates a line of code for an event every 0.05 seconds. And it clears the other timer as this one's active. But the difference for this one is that this is for cooling down the jetpack when it is not in use. So for this, we run this line of code that initiates only when the current fuel is above the max fuel, which is set to 0. I know my variable names are a bit odd, but please bear with me. Anyway, as the current fuel value is above 0, it runs a lower gauge function right down here, which if we open it up, we can see that it takes the current fuel value and lowers it by the regen rate, which is set to 1, and sets the new value. So in short, this line lowers the fuel value by 1 as long as the value is above 0, and the key is released, and it does this every 0.5 seconds, which reduces the gauge at the same rate as the other branch when the gauge raises. So yeah, I know that was a lot, but here we're almost done. So in fact, this is the last thing to go over in this branch. This is the clear timer for when the condition is met, so it turns off the timer when it no longer has heat to cool off in the gauge. Then it clears the timer again in case of glitches. So yeah, there we have it. That was my jetpack functionality for the player character. Now moving on to the other keys that the player can use in the level. So up here we have a toggle inventory key on the tab key. I'll be going over this more in a minute, but this uses a function from an inventory component that I made that toggles the inventory for the character to use. Next, I added a sprint functionality that admittedly did not see much use in this vertical stage, but it's still a nice feature to add in case of future expansion. So here I have a sprint button that works much like the same way the backpack is used, but here I actually have two functions, starting out with my start sprint function. Here I have a particle effect of smoke at the character's feet that activates as the button's held. So this is here to signify that the character is sprinting because it's not immediately clear that the player is sprinting except for a small amount of motion blur. But yeah, that's what the smoke particle is there for. But here in this next node, this actually sets the character movement speed to the new float value and allows the player to run faster. So that's the exact same philosophy for my stop sprint function, except it deactivates the smoke when the button's released. It sets the new value back to default walk speed of the character. So yeah, that's that. Up here we have a the player can restart the level on any R key. It just uses a console command to restart the whole level. This is useful because it clears all the values of the level, so there's not any weirdness with the math. Next up, this is where the player can actually pick up items on a Q key press using an interaction interface. So it gets the array of items. It gets the array of items and allows them to actually be interacted with, and uses functions from the inventory component as well, which again I will be getting into in a second. And yeah, here's the actual interaction interface itself. You can open it up and yep, there it is. So anyway, moving on to the timer functionality, which I'll admit I'm not too happy about it. I may go back in the future and change it because it uses an event tick, and I'm well aware that it does use a lot of processing power and it's not very efficient. So I will be looking for alternatives, but for the purpose of this showcase, I believe this works fine in this instance. So anyway, it uses an event tick as the level begins, and it acts on a 1 second delay to actually simulate the speed a normal timer would go. Then it goes to a statement that runs one of two pieces of code where the seconds integer is 0 or not. So if the condition is false, then it decrements the seconds integer by 1. So if the value is like 9, then it's going to go to 8, 7, 6, 5, and so on. Then if the value is 0, then it's going to check if the minutes value is 0 or not. And if the condition is not met, then it will decrement the minutes integer by 1 and set the seconds back to 59, similar to a clock. Then it's going to keep checking the seconds. It's going to keep checking the seconds and the minutes. It's going to keep checking if the seconds and the minutes are both 0, and if both conditions are met, then it will run through this final line of code for the timer. So in this line, right here, I have a check here, which keeps the timer death screen from showing, because as the event tick is going, it will still run this line and keep printing the death screen. So I just made a new Boolean value as a way to check if this line of code has been iterated or not. Then it creates a death screen for the player to see, ragdolls, and sets the game mode similar to the player death for the jetpack overheating. So yeah, that was a lot to go through, but yeah, moving on to the last bit of my third-person character blueprint, we got some miscellaneous nodes. So here I had to create a new input for upward movement for the jetpack. So I made this little function here and connected it to the character movement right here. This adds the HUD to the screen that displays the heat gauge and timer. And finally, this creates a windscreen when the player makes it to the top of the tower. I have it set the game to pause to prevent the timer death screen from printing over the windscreen. So yeah, that's just about it for my third person character. I will now be moving on to how my inventory system works with my inventory component. All right, so in my inventory component, I have 4 override functions, which essentially act as event dispatchers to initiate a line of code when the dispatcher is called from other blueprints. So in my event graph, I have a prepare inventory function, so I guess we'll start there. So what this function does is it actually builds the inventory at the start of the level so that things can be placed inside the inventory array. Next up, I have my create item function. So what this function does is it creates an item that has attributes that match with the inventory array so that the item can be placed inside of said array. So in this case, it's getting values from an item class I created, and we'll be going into further detail in a second. But yeah, it takes the values from the parent item class and allows it to be added to the array. Next up, we have the actual add to inventory function, which uses the create item function to create the item, then uses slot structure to add the item and show it, to add the item and show its thumbnail in the inventory window. So this function is also used by the interaction interface in the third person character blueprint. Finally, in the inventory component blueprint, we have the toggle inventory function, which is also referenced in the third person character blueprint on the tab key. So here, this is the function that displays the inventory window for the player to see, and they can toggle it off the screen if they wish. So here I have the basic toggle function, which toggles between 2 branches of code. I'll start with the actual creation of a window. So in this line of code, it creates an inventory window widget that I created and sets it so the player can see it. It then adds the child to the canvas, so what this means is it adds the item to the inventory window canvas for the player to view. Then over here, it then sets the location and the size of the window by getting references to the anchors in the widget. So in this case, it sets the window to the bottom right of the window when the player presses the tab key. Then these nodes add the mouse to the... Sorry about that. Then these nodes add the mouse to the screen so that the player can choose which item to use at the click of a mouse. Oh, and it also pauses the game so the player can have time to think about what they want to use and get maximum value out of the items while the player is suspended in the air, if that makes sense. So they can't just fall down to the bottom, then use the coolant, then it's just a wasted item. Then when the player wants to remove the inventory window from the screen, they can press the tab key again and run through this line of code, which removes the window from the screen and turns the mouse cursor off so the player can no longer make mouse inputs, and it sets the game back to unpaused. And all of this is behind the tab key in my third-person character blueprint. Yeah, so that just about does it for my item or my inventory system. I will now briefly be going over the item class, which is apparent to another class. I want to have the basic values of the item that can be shared across multiple items. So I made this one a parent class, and the specific subsets of items become the child classes. So anyway, here I have a dispatcher for my interface that uses the override function from the inventory component to add an item to the array and create a slot for said item. It will then destroy the actor in the overworld when the item is interacted with. So yeah, that's all that is fairly straightforward, but next up is the inventory, or the coolant item, which is the child of the item class. I wanted to have multiple items initially that could be placed in the inventory, which is why I made the parent class, but this is my only child class in this level. So I may not have needed the parent class to begin with, but it's nice to have the option in the future to easily create more items if I decided to pursue this. So starting here in the use item function, it uses a function from its parent class for when the player wants to use an item. It then casts to the third person character so that I can use the values from the blueprint and edits those attributes like so. So the item's intent is to lower the gauge by a certain amount when the item is used from the inventory. So here it subtracts from the current fuel value in the third person character, then sets the new value. Fairly simple item use, but it gets the job done. Then in the event graph, I just have a simple particle effect that activates or turns off if the player is standing over it, so it shows sparks flying out of the item if the player is standing over it. Oops. So yeah, that about does it for my inventory system, which is another major part of my level that I felt I needed to go over in detail. So up next is my actual HUDs and how I was able to display my values to the screen. Yeah, so starting out with my actual progress bar, I have a character reference to my third-person character that gets the values from that blueprint and uses the two float ints, which is current fuel value and max fuel value, and divide them to get a number between 0 and 1. So the purpose of getting a value between 0 and 1 is because the progress bar works on a 0 and 1 scale and not a 0 and 100 scale like many would assume. So it gets that value to display in the progress bar that it is binded to. Let's see, next up we have the timer, which is actually fairly simple. I just took the int value from the third person character blueprint and converted it to text, which is then binded to the corresponding text box right here. So in this specific example, this one is seconds and is binded to this box, but the code is the exact same for the minutes, except it uses the minutes value and is binded to this box instead. Next up is my menu HUD, which I did not showcase in my short video, but I still wanted to show it off a bit. So here's my actual HUD menu screen using visuals from the Virtus tutorials that were provided. Then in the actual menu, I have this line of code which sets the input mode for the character and lets the player use a mouse cursor to select an option on the menu. I then have sounds that play. Excuse me. I then have sounds that play when you hover over a button, which is a nice little coin chime. I thought it was nice. In the open level function, it gets the name of the level and opens it. Fairly self-explanatory. Most of this menu is just console commands, just like the exit, which uses the console command quits when the button's clicked, so that just closes out the entire game. Alright, now the final thing I will be going over is my moving spline platforms. So I accomplished this by using a timeline right here that activates when the player steps on its trigger box. It then plays in reverse, so it goes back to frame 1 position when the player leaves it. This function right here, this gets the actual spline length and gets the location values along the spline where the timeline is calculating from a 0 to 1 value. So as the timeline moves on, it sets a new location value for the spline. So at like 1 second, it sets the world location for the mesh so that the spline is so that I got mixed up. So as the timeline moves on, it sets a new location value for the spline. So at 1 second, the world location for that object is here, and then at 2 seconds, it's here, and so on. Let's see. Then in this function, it sets the world location for the mesh that the spline is attached to, and theoretically moves the mesh along the spline. And yeah, that's how I get my platforms to move along a spline. So anyway, that was my commentary on my code breakdown. I hope that was enlightening for you, and I appreciate you taking time out of your day to watch. So yeah, thank you very much, and have a good day.